And thanks to Frontmania for inviting me to speak. It's an honor. And thanks to my employer, Sirius, for letting me speak to you on company time, because getting paid to speak is always better. So, porting React code to Vanilla.js for fun, because it's sort of a hobby of mine. And I know, don't judge, but everybody needs a hobby, okay? So I hope you will see that this can actually be a fun thing to do as I go through it. Now, this didn't used to be a hobby. This used to be my job, writing Vanilla.js. Why? Because I started professional web development in 2005, and back then we had only Vanilla.js. We didn't have jQuery even. There was nothing. There was just your widths and your editor and your web server, and we had the glory of Internet Explorer 6. Wonderful product. No, not really. It was a terrible browser. It was absolute rubbish. I will be honest about that. It was slow, like incredibly slow, and machines back then were much slower, and IE6 was really slow. It had terrible standard support, like really painful, and back then the standards were much smaller and less capable, and even then the standards that we had, it supported quite badly. It leaked memory like a sieve. You could declare a variable wrong and it would leak memory, and it had no dev tools. And yet we loved it because it was the first browser in which you could build a single page web application, and that made it special. That made it amazing, because we could actually explore what it meant to build single page web applications. But we quickly learned that if you did it vanilla, that this was incredibly painful, like only a masochist would want to do such a thing. Because you needed to know a gazillion hacks to make IE do the thing you wanted it to do, as well as make it work in Firefox and the other browsers which came along later. So all of this knowledge and all of this effort, everybody wanted to get away from that and have some kind of tool that fixed that problem for them. And so we got all of this. We got all of these libraries and frameworks and build tools, and they all solve this problem of how do you build a magnificent castle on top of a swamp. Because IE was the swamp, and then these frameworks, they put a foundation on it, and they built these castles. And they built these castles taller and taller and taller, and so they were doing all of this work to make the swamp better and better supported so that they could build these castles taller. On the one hand, this made web development a lot simpler because you didn't need to know a lot about the browser anymore. On the other hand, it got way more complicated because now we needed to know a lot about the tools. And the tools, they got more and more complicated over time. But I could understand why. Like, I had done what they did directly on the browser, and I knew why you didn't want to do it. So it all made sense with me because IE was a thing. And then this happened. Microsoft said IE is not a thing anymore. So I was like, okay, frameworks, what are you gonna do? You're gonna simplify it back down, like you're going to take this new foundation of capability like Chrome, Edge, Safari, Firefox, they're amazing browsers, great web standard support, super fast. You're going to slim all of that complexity back down and make something super elegant and simple. And then they didn't. They ran to the server and they built more complexity, and it's like way more complicated than ever before, which was frustrating for me. So I went on a bit of a vision quest and tried to figure out, okay, what does it mean to go back to basics? If we put aside all of that stuff and we try to figure out, okay, what's the basic web development patterns that we can do directly on top of browser API? So that's what I want to cover with you today. I'm going to be bringing over React concepts to vanilla. Now, all of the stuff that I discovered as I was doing this, as I was exploring all of these concepts and building like sample code and making notes and doing researches, I built this huge notebook and this big collection of code, and I put it all up on this site. So everything we're going to cover with you is on there. If later on you want to go there, I have the link as well on the final slide. But this is basically a framework tutorial for web standards, if you're interested in such a thing, which is admittedly a weird thing. Right, what do I mean by vanilla? I mean web development without build steps and without dependencies. So that includes NPM. if you started doing web development in the last 10 years, this seems decidedly weird, I know. Because, like, why would you even want to do it? It's like tightrope walking without a net. It's so dangerous and weird and difficult and like, no NPM? Seriously? Yes, no NPM. We're going to go into the mindset where it's like 2005 and we have our editor and we have our static web server. We have web standards. We're just going to do it. Okay. When we go to the React website and we go to their tutorial, they explain the concept of a component through this code. They explain this concept of, look, a component is basically a way where you can generate a bit of HTML from some logic and some state. That's basically what a component is. And they show the MyApp component and the MyButton component, and it renders this basic example. So whatever we're going to do on the vanilla side, it has to do that. It has to have this concept of components that do something like this. But it's never going to be that elegant. I mean, of course it won't be. You could do this in a ton of ways. I'm going to do it in the way that you might have expected. I'm going to use custom elements, or as they are known in marketing lingo, web components, which always incites hate, as anything marketers do incites hate. But custom elements, which is much less controversial, but exactly the same thing, is what is being shown here. So it's as simple as we extend a class from HTML element, and yes, it's class-based, so it feels like you're traveling in time back to some old school Western-themed place. And then we register that class with the custom elements API by just saying custom elements.define. We give it a tag, and then we give it the class, in this case this, and in this way our button gets registered so that we can start using it. The same for app. We can also define the app component as a custom element in this way. And as you see at the bottom there, we can use the MyButton tag in the markup, and it will work because we've already defined it in the custom elements API. This means we can extend HTML with custom elements, and we can make them do, well, basically anything. We can, there's no limit to what you can make a custom element do. The only limit is your imagination. So let's explore. The next example, as you go further through the React tutorial, is they give you this tic-tac-toe game, and it's already quite a complicated example. I can imagine beginning developers really struggling with the concept. So you've got this tic-tac-toe game with the current player state shown. You can click X or O, and then it shows you a history of moves, and you can actually time travel through a previous state of the board by clicking the button and start playing from there. So already that's quite complicated to do that. The way that they implemented it is 4 files, but I'm not showing you styles.css, but there's a styles file as well. But index.html, the template of course, index.js and app.js, which contains 3 components. Game component, which contains all the state, the history of moves and the current move. The board, which is the part that actually shows the X and the O's, and the square, which is 1 square on the board. Now what I found is you don't need to change the structure. When you're bringing something from a framework over to vanilla, to modern vanilla, you can keep the exact same structure of components and files. So I'm going to keep the same structure of components and files. I'm just going to bring that over. Index.html, well, on the React side, we had a build tool, and it's bundling our JS and bundling our CSS and injecting that into this HTML template. On the vanilla side, we don't have that. We have to include those files ourselves. Now for JavaScript, we use type equals module so that we can use ES module support, and now we gain import and export ability inside of our vanilla code base. That will just work in the browser, in all of the browsers. So that's not very complicated. Styles.css, like I said, I will not cover it any further because it was already vanilla CSS on the React side, so we can just reuse that. I think more and more developers are figuring out that you don't actually need more than vanilla CSS in most cases. So as we go along, the nice thing about it, if you have a code base which is already vanilla CSS, you can just keep that part and change out the JavaScript side. The index.js file more is happening there on the React side, of course. We're importing the framework. We are importing the app components from the app module. We are getting a handle to the root element and then rendering the app components to that root element. Vanilla side, we're doing the exact same thing. We're importing the app custom element, which is in a module. We are obtaining a handle to the root element, and we're appending the custom element for the game that implements, the custom element that implements our entire tic-tac-toe game to the root elements. Now the name is x-game. That's because there's a rule that custom elements must have a dash in their name. So if you are really clever, you can find a way to hide that and make it seem like, hey, I meant this all along. But if you're not clever, you can do x- and then, yeah, that's what I did here. I'm not that clever. Before I go on to the game component, I need to talk about state. The way that state is handled in basically every framework is that they try to touch the DOM as little as possible. And they have all of their components over on the JavaScript side of the fence. You have your entire component hierarchy, and your state will be living in that component hierarchy. This is even true in React, where like it pretends to be functional, but really what you are building is a stateful component hierarchy, and the functions are the way that you build it. But underneath, it's just that. It's components that carry state, and that there are events that are happening, and they are being sent up your component hierarchy, and they're updating your state. Then at some point, framework magic intervenes from the heavens, and it renders your component hierarchy to the actual DOM, to HTML, so that the user can see something and interact with it. But crucially here, the state lives outside the DOM. When you move over to a concept of custom elements, your state lives in a custom element, so it becomes part of the DOM. You're just flattening the tree. It does not actually change the structure. You still have the same components, you still have the same markup that's being rendered. You put your state in the same places, you're updating it in the same ways, you're communicating in the same ways, but everything gets flattened into the DOM, which is a mindset shift, but there's pluses and negatives about it. Let me just say it like that. It's not all bad. There are good parts. So yeah, Vanilla.js, there are also good parts. Like I'm really trying to sell it here. The game component. On the React side, they set up this state, the history of board moves and the current move. This is the actual state. Then they have some derived state. Is X the next player, and what is the current state of the board, like the current squares that have to be shown. And then some setting up of event handlers, and they rendered out the actual markup of the game with a board component in there, which will show the board. We can do the exact same thing in our custom element, because you can make a custom element to anything, except now a custom element lives in the DOM, so we have to attach our state to that custom element, which we do as properties instead of variables. So now these are the history and current move are properties on our class, and we can set up derived state as calculated properties that only have a getter. And in this way, you can basically have the exact same structure of the way that your state is handled, but do it purely vanilla. Now, the rendering side, that's where things always get hairy in a vanilla web code base, because we don't have framework magic anymore. It's not helping us out. Framework magic allows us to define a reactive template where the framework will figure out, okay, are we rendering initially? Are we updating? What state has changed? What do I need to change in the DOM? On the vanilla side, we have none of that. So what you will typically see is this pattern. You've got the unconnected callback, which is called when our custom element initially is attached to the DOM. We're setting up an initial raw structure that we will use later on and attaching event handlers to it. And you can attach these event handlers higher than where the events will be called, because we can leverage event bubbling. And then you have an update function, and the update function will be called every time the state changes. But we have to call it every time the state changes. That's on us now. There's no framework magic. We have to do it. The bad thing about this, we have to do it every time. The good thing about it is we know when it happens. So you don't get these sudden unexpected re-rendering situations or stuff like that. You have a lot more control over what happens in the code base, a lot more just understanding in general. Like there's less surprises when you're working in a vanilla code base. You see there also that we're sending this update down by calling this .board.update and passing it the updated state. I'll get to that later. All right, so the board component. This is interesting on the React side because this is a stateless component. This is a component that does not have any state of its own. It just gets passed some props and it sets up some handlers and then it renders markup. So every time the props change, we're just going to run through this and then generate a new markup. Now, this flies in the face of the concept of, but my custom element lives in the DOM permanently. Like, how does that even work? Well, it works by just moving all of the logic into the update routine, because all we're doing is updating, and the update routine gets the new props, between quotes, the new state that it needs to render, and it's just going to re-render everything. Which means it's going to reattach the event listeners, and you might be thinking, don't we need to clean those up? Because back in the IE days, we would have had to clean those up, but modern browsers, they all will clean up event listeners that are attached to DOM elements which are no longer attached to the DOM. So you don't actually have to clean them up. They will get cleaned up magically by the browser, which is a very nice thing. By the way, DOM events, awesome. I am a massive fan of DOM events. It is the best event system of anything I've ever worked with. I cannot sell it enough. It's amazing. And it's amazing to build all your logic around DOM events because they're super powerful. Although verbose. I will concede to that point. All right. The square, that part is uninteresting and ugly on the vanilla side because I used raw DOM API calls. The only part I want to point out there is the dispatch event call, which dispatches a custom event, square click. And yes, you can just dispatch whatever event you want. There's no rule that says you must dispatch a known event type. There's nothing limiting to you on what you can put on an event. You can attach any kind of property or behavior to an event that you want. The browser will just use that. As long as it's subclassing event, you can do everything you would do with events normally, which is a super powerful tool. It's like really powerful. So everything I've shown you up to this point, like there was no generic code in that. Like it was just the code that you were seeing, and there was no abstraction layer, there were no helper functions, there was nothing like that. You can already do a lot in that way, but you will struggle once you get to the more complicated concepts from the frameworks, because they really rely on these abstraction layers, so you have to bring up a little bit of abstraction into the vanilla code base as well. But if we do that, if we allow a little bit of helper code to show up, what could we tackle? Well, we could start, for example, by looking at contexts and reducers. So skipping all the way to the end of the React tutorial, the final example they gave of the glory of React is this application, a to-do application, because of course a to-do application is the best thing to demonstrate the glory of a framework, which is built around the concept of a context and a reducer, where the context sits high up in the component hierarchy. It contains all the tasks. The tasks, they get rendered into the UI of the application. Whenever the context is updated with new tasks, the UI will re-render automatically. Then if the UI dispatches an event, then this obtains the dispatch context, basically a function that it obtains from the context, and calls it with an action that says, I want this thing to happen to the tasks. This gets fed through the reducer, and the old tasks combined with the action produces the new tasks, which updates the context, which re-renders the UI, and so on and so on. It's a very nice concept. It's a very good way of scaling up your application while still keeping it manageable. So they have this reducer in their example, and if you pay close attention, you will see that this is all vanilla.js. So this is React code, but it's also vanilla code, which means I will use it verbatim. I will not touch it. So this is the reducer we're going to use in the vanilla code. If we then skip to the application component, well, you see that in React it's very nice. We have our tasks provider, and then inside of that we have the components which we want access to have access to the task provider and its tasks and dispatch function. On the vanilla side, we have our tasks context. A custom element is going to fulfill the same role, and everything inside of that can get access to the context. By which I'm, of course, whetting your appetite, like how does that work? But I'll get to it. The React context implementation is quite verbose. It's complicated, it's meant to be complicated because it's doing a lot of stuff, but in essence, it's providing the tasks and the dispatch and wrapping that in a reducer. So that's what that React code is doing. This is actually way simpler than it used to be if you wanted to do reducers, so they already did us a favor there. On the vanilla side, it's actually simpler, which you wouldn't expect, but it is the case. So what you see here is a custom element that will be implementing the context. It's a non-visual custom element. So in connected callback, the only thing we're doing is saying display equals contents, which means it will take itself out of the rendering hierarchy and it will render its children instead. So it's non-visual. You cannot do that any place in HTML because there are accessibility dragons. If you try to do it in a form, you will have very bad experiences. But doing it top level in the hierarchy for context is actually fine. And it has two properties, two providers for tasks and dispatch. And there it uses a little bit of helper code, a tiny library that provides this context provider. This library is only 35 lines. I will show you in a second. So you only need 35 lines to do this thing. So these two providers, they provide the tasks and the context where, yeah, the code is right there. It's not super complicated. Like you read this and you see what it does easier than actually on the React side of things. Now, how does that actually technically work? Well, there is this, well, this pattern standard. I don't know what you're supposed to call it. The Web Components standardization group came up with it. It's a way of doing context between web components. So the way that it works is you have your consumer, which needs context. It dispatches a context request event, which is a custom event type. This event will bubble up the hierarchy to wherever it finds a listener that provides that context. That listener will stop the event from propagating further, and then it will strip the callback function of the event and call the callback with the asked for context. There's also a subscription mechanic if you want to use that to be subscribed for updates, and then your callback will be called every time the context changes, which solves like basically 80% of what React context does. And you see that on the dispatch side, it's just dispatching an event. So we dispatch the context request event, and then we get passed in our callback what the dispatch function is, and we can call dispatch function to add a new to-do to the tasks. The nice thing about the dispatch event API, it is a synchronous API. So we can call dispatch event, obtain some context, and then after that call, just continue as if the call already completed, because it already has. It's a synchronous API. So that's quite nice. And then this is that actual code of that tiny library. So like 1/3 of the code is defining the custom event type. It bubbles through composed through. Composed actually means it will pierce shadow DOM boundaries. So you can have a context even if you're using shadow DOM in your code base. You can have top level context, and the event will bubble up through the entire hierarchy all the way to the top. And then the right side is this provider. I know this code is somewhat small to read, but basically it's just listening on a DOM element to context request events, seeing does it match with the type of context that I think I am, and if that is the type of context that I think I am, I will give you the value in your callback. That's more or less what it does. There's some subscriber logic, but that's not super complicated subscriber logic, but that's all that it does. It's not super complicated. This is not the only implementation, but this is the shortest implementation. There are other ones which do it a little bit more fancy, but this gets the job done and it's spec compliant. All right, so that's context. That's already a pretty complicated thing. We needed 35 lines of code, of helper code to do that. Suspense. That's going to be a little bit more complicated. Now, when you use suspense in React, like for example, you're doing a dynamic import of components. So you have a lazy wrapping a dynamic import. And then while that component is importing, there's basically a promise waiting to be fulfilled. That promise will be passed to the suspense component. Then as long as that promise is not fulfilled, it will show the fallback component, your loading component. And when it's fulfilled, it will show the actual content. If something goes wrong, because a promise is only a promise and a promise can be broken, then we need to do something with that, and then the error boundary will pick that up, that there's a failed promise, and it will show the fallback component instead of the children in the hierarchy, so we can have some kind of oops page there as well. So there's a lot happening there. It's quite complicated. We're going to have to stretch our imagination to bring that over, but basically we're just leveraging events again and trying to do it in a clever way. So this lazy component, what would it do? Well, for example, you could have, and I have an example of this actually on the GitHub, I will have the link at the end, but you could have an intersection observer that notices when the lazy component becomes visible. Intersection observer is rarely used, but quite useful API for doing that kind of thing. There's also a mutation observer to know when DOM changes happen. Also very useful when you're writing vanilla web code, not much used in frameworks because frameworks use it themselves and they use it as part of their magic. But we can have this intersection observer. It sees when the lazy component scrolls into view, it walks its children, sees which ones are custom elements. There's a way to do that quite easily to detect that an element is a custom element, and that isn't actually defined yet. And then you can have some kind of convention of figuring out which file does that map to that custom element. It could be with an attribute on the custom element. It could be with some kind of feature-based folder structure, which is by convention. I like the convention approach myself, but it's vanilla, so you can do whatever you want. And then it will load it, and while it will load it, it will dispatch events that basically say, this is what I'm doing right now. So the suspense component, the suspense custom element, what that is doing is just listening to those events. And when it notices that something is loading, it will need to be showing the fallback content. And when loading is done, it will be showing the regular content. That uses Shadow DOM. Shadow DOM has this capability of slots where we don't have one set of children, we have as many sets of children as we want, and we can choose which ones we are showing at any time. So the components that we put in the fallback slot will be shown at the fallback time, and everything else will be that it goes into the default slots, it will be shown in the normal situation. If something goes wrong, again, we can broadcast events for that. They will bubble up and they will reach our error boundary, and it does basically the same thing as suspense, but now it does it for errors. So you see, this is all just like imagination, like looking at this toolbox that the vanilla standards provide us and figuring out how do we wire those together in a simple way to get like 80% of what React would give us and just get the job done that we're trying to do. So that's 150 line helper. So there's a lot more code involved there, but on the other hand, it's only 150 lines. So it's not dramatic. I mean, like, we always have this idea that, oh, this must be thousands and thousands of lines in these frameworks. Yeah, in the frameworks, it's thousands of lines because it has to fit in the structure of the framework. But if you don't have to make it fit into the structure of the framework, it's not actually that much code. All right, routing, client-side routing, another one of those like typical things. You would use React Router, for example. Well, we can have custom elements that just implement routes, and they can watch what is the current location of the page. And if that location matches the expression of their route, then they can show their children, and if it's not matching, they can hide their children. So that does not do the same job that React Router does, and I will not pretend that it does, but it does do the job that a lot of applications need, which is a lot less fancy than what React Router does. And what you see here on the left is actually the example application that they provided on the React blog when they announced Vue Transitions. Because the Vue Transitions demo application, it has this implementation of routing, but it also has this implementation of Vue Transitions, which is like really nice. So Of course, I had to port that as well. I couldn't leave it alone. So, but that's actually another 200 lines on top of this generic routing solution. So with 300 lines of helper code, you can actually port over the React example, and I think it's like 1.2x the lines of code as the React example once you subtract the helper code. So it's not actually that much more code. It's not that much more complicated to follow along. It's structured in exactly the same way. The power of being able to do this stuff outside of frameworks, you're not bound to the constraints of frameworks. So like I said, it's just like, what can you imagine? How can you look at this toolbox and reinvent it in a clever way? But once you get to 300 lines of helper code, it's micro framework. So at some point, you have to make the call, is this still vanilla, or should I just use a micro framework, or maybe like use a real framework? Now these are micro frameworks which can be used without the build step. Like I think that is valuable to not have builds in some cases. Lit is of course the elephant in the room in the no build web component space, but the other ones are interesting as well. Preact is not web components based, but it sort of floats in that micro framework arena. And I don't want to pretend like let's just throw away all our frameworks and let's just do React because let's do vanilla because vanilla is great and awesome. There are real downsides. I will not pretend that there aren't. If you want to bring third-party libraries into a no-build code base, you're going to have to real pain because the NPM ecosystem is not designed to do that. There are ways to do that. I cover them on the site, but not all libraries can be brought into a vanilla code base, and it's somewhat cumbersome to do it. But if it's on a CDN, usually you can bring it into a code base. We don't have standardized server-side rendering. Lit has a way of doing it, but only for lit-based code bases. So like Lit is this weird intermediate between a framework and a way of building web components. Depending on how you use it, you're using it as a framework or as just a way of building web components. There's no generic way of doing it, and there's not even a proposal of a generic way of doing it. So nobody has a handle on server-side rendering right now. I would question if you need server-side rendering, because typically we're not doing that for SEO anymore because Google evaluates all the JavaScript client sides just fine. But we're doing it for performance, and typically a vanilla code base will be so tiny that is fast no matter what you're doing. Like there's so little code involved, like a few kilobytes of code maybe, like it's just not a lot of code involved. So it's going to load fast no matter what. And that means that you probably don't need server-side rendering. But yeah, maybe you do. It sort of depends on the circumstance. Reactive templating is the biggest downside. That's the thing that I miss most when I'm working in a vanilla code base, because you really want to have this template that you can plug in your state into and that does the writing automatically. There's a proposal for a standard to add to browsers, but it's early, so it's going to take a while. Signals also still a proposal. It's not finalized, but it's closer. I think once we have signals and we have reactive templates based on signals, and expect we will have that in probably 3, 4, maybe 5 years, something like that. So that's quite a wait still. But once we have the standards, we can have a polyfill. So I'm hoping, fingers crossed, we will have that. I think that solves most of the problem space of vanilla web applications. Then it will actually be relatively easy to do the stuff you were doing in frameworks in a vanilla code base. Right now, it's still sometimes, depending on what you're doing, cumbersome. And that means that the developer experience is not all there. You'll find that a lot of tools, surprisingly, struggle with vanilla code. You wouldn't think they do, but they do. And also, like the syntax in general, the browser APIs are not super elegant. The framework APIs are usually a lot more elegant. On the other hand, the LLMs are super good at writing vanilla web codes. They don't hallucinate browser APIs that don't exist in my experience, because it's so baked into the training materials that you don't have this problem. So a lot of the ugly boilerplate, you can just have the LLM write it for you, and that means that your pace, your progress is actually not that bad when you're writing a vanilla project. So on the upsides, why would you want to write a fully vanilla code base? Well, first of all, I think it's fun, but I'm weird, but I think it's fun. Yeah. there's no churn. You don't have dependencies that change suddenly. Nobody who's telling you need to upgrade this or that framework or tool or whatever. And I struggled a lot with this in the past decade with like forced upgrades on code bases and just having a lot of pain, a lot of retesting. You just don't get it on a pure vanilla code base. There's no churn because web standards, they're not forever, but they're forever in IT terms. Let's just state it like that. You can build something, you can ship it, you can come back to it 10 years later, add a feature, and it will be just fine. So that's quite nice. These code bases, they're also quite understandable once you have a good solid grasp of like basic browser APIs. There's a bunch of browser APIs which you're probably not used to working with, like custom elements, like Shadow DOM, stuff like that. Once you're used to working them, if you're in a vanilla code base, like it's really straightforward to follow, and it's all web standards, which means it's transposable knowledge. You can reuse it in a lot of places. And that means it's also like it's all cross-framework. React 19 now has better custom element support, so now we can bring custom elements into React code base much more easily. They don't get server-side rendered. That's a downside, but we can use them in every framework, meaning that like if you have this thing like I need to build a widget and the widget needs to be dropped into all kinds of websites and I don't know what they will be built in, just build it as a custom element. It will solve your use case just fine, and you can write it fully vanilla. You don't have to use any framework to do it. It's fine. And you will have an okay time once you get past this knowledge hurdle. So yeah, that's porting React applications to vanilla.js. A weird hobby, but I can only recommend it to everyone. It's fun. Thank you.
Yeah, we do have some time for questions. Thanks for the presentation. I think you shared quite some insights on it's doable for like 90-95% of the use cases. Where do you see like in the future? Will we ever reach the 100%?
Well, we're always going to play catch-up to what the frameworks are doing, no doubt, but currently the frameworks, they are sort of doing self-inflicted wounds, like they're off doing this weird stuff, which a lot of developers honestly don't need or haven't been asking for, and that means that the gap is shrinking because they're spending all their cycles on that. Once they get that out of the way, probably the gap will get a bit bigger again, but the browsers are always up-leveling, and every year we get all the browser makers, they come together and they talk about what do we need to add this year, and they agree on which web standards need to be implemented that year. So we used to have this problem of like this very uneven evolution of browsers, but the past few years you see that every year we get this Easter treats, like every year this gift of new features landing in the browsers, meaning that once the browsers roll out, and we're like a few years down the line, that's your new baseline. So now we have this concept of baseline, which everybody's sort of getting a handle on. And as long as you're targeting like a baseline of like now 2023, something like that, it will work fine for your customers probably. And then, yeah, it's perfectly doable.
Sounds like the opposite of IE6.
Yeah. There's, I mean, I only have respect for the browser makers. They're doing a very hard job and they're doing it very well. People like to criticize Safari and Firefox teams, but I have sympathy for them. It's a hard job and they do it without much thank, so I thank them for doing it.
Thanks for them. All right, any other questions?
Everybody's blown away.
Quite a lot to digest also.
The magic of vanilla.
Yeah. Certainly is. Thanks a lot. Yeah.